we are going to jump in here. Now this again, okay, this one that says 7.2 division exponent rules. This is notes. Again, this is the stuff that you can use when we do quizzes and tests and stuff like that, if you need a little extra reminder on things. So we're going to start with the dividing exponents, then we'll kind of blend the other things back in. So here's how this works. If I have something like x to the 4th over x squared, now again, I'm going to look at it in its long version on a couple of these. We're not going to be doing this in every problem, but I want you to visually see how this works. X to the 4th means I've got 4 x's that I'm multiplying together. X squared means I have 2 x's that I'm multiplying together. Whenever we have a fraction, visually, if I have the same thing in the numerator and the denominator, I can cancel those. But I can only cancel them until I run out of x's somewhere. So in this case, I ran out of x's in the denominator, but I've still got 2 left that I'm multiplying here. So my answer, since I have 2 left up top, is x squared. Now, we started to talk about patterns yesterday, but here I'm not quite sure because 4 divided by 2 is 2, but 4 minus 2 is also 2. So maybe we better try another one here. So x to the 8th, and again, we're just drawing out now so we can visually see the rule. All right, I have 8, yes. So we're multiplying 8 x's together. And the 5 just means we've got 5 working along here. Shh, shh, shh. Same idea. If I start wiping them out until I run out, when I run out, I've got 3 left, so I've got x to the 3rd, but it's up in the numerator. Now I might start getting an idea of how this works. 8 divided by 5 isn't 3. 8 minus 5 is 3, though. Wonder if this is going to keep working. So one more time with it the long way, and then we'll get the rule and we'll start shortening this up. So up top, I got a 4. X to the 3rd means I've got 3 x's that I'm multiplying. And y to the 6th means I have 6 y's. And I'm just going to keep stressing, we're not going to draw these out forever. We're just taking a peek to see how this works. So then down below, I've got a 2. Wow, 7 x's. Who was thinking when they put this sheet together? Not me. So 4, 5, 6, 7 of those. And 3 y's. Eric, close that for me. Thank you. So, first things first, what's 4 divided by 2? 2. Okay, since the 4 is up above and 4 divided by 2 is 2, I put the 2 up top. So then I start working through my canceling again. So I start wiping out x's. Well, I run out of x's up top this time. I've got 1, 2, 3, 4 left, but they're down below. So that's where I'm going to put them. I have to put them where they're left. And if I start doing the same thing with my y's, until I run out, I've got 1, 2, 3 left, but they're up top. And that would be my final answer. So here's how division works. There's kind of 2 parts to this. Okay, first, I'm going to subtract the exponents, but I'm always going to do it the bigger exponent minus the smaller one. I don't care where it is right away, but I don't want to end up with negative numbers. So I'm going to do big minus small with my exponents, and then the answer goes with the larger exponent. And once I give you a chance to get that jotted down, I'll explain exactly what I mean with that. because this ends up being easier than just always doing top minus bottom and then having negative exponents and having to play that game, even though we'll talk about that a little bit. So here's what I mean. If I go back and I look at the example we just did, example C, 7 minus 3 is 4, but where is the bigger exponent at? It's down in the denominator. That's why my x to the 4th ended up down here. When I go back, let me make this a little bit bigger so we can see these a little bit simpler here. When I went and did it with the y's, 6 minus 3 is 3. The bigger exponent was up top in the numerator, which is why my y's ended up there. If you just follow that as your basic rule, it keeps life a lot simpler. So as we get into some of the examples down below, okay, so like let's say we're just do number 1. Yep, subtract your exponents is 1. X to the 1st, does it end up top or down below? Up top, because there's my bigger exponent. Now you can put just x to the 1st or x. If you wanted to put it over 1, you could. Okay. Yep, we're just subtracting the exponents. So x to the 1st or x would be fine. If we're doing number 2, 9 minus 5 is 4. X to the 4th.
So you just subtracted it?
We're just subtracting it. Now, again, I have to pay attention, though, to where it's at. So, like, for instance, let's do number 4. Okay, with my x's, I got a 6 and a 5. So 6 minus 5 is 1. Does that x to the 1st go up top or down below? Up top, because 6 is bigger than 5 is. So x or x to the 1st would go up top.
There'd just be one regular y, right?
And then, well, let's look at the y's. I got an 8 and I've got a 3. What's 8 minus 3? 5. Where's the bigger exponent at? Down below. So my y5 goes down below because that's where the bigger exponent is. So I'm always subtracting, but I'm always doing bigger number minus smaller, and then my answer goes where the bigger number's at. What's that? Only for the exponents. Yeah, this is only rules for exponents. Yeah, so like if we were doing 5, now 2 over 3 is going to give me a decimal. I don't want to put decimals down. So if I get something with a decimal, I'm just going to leave the fraction part there. I'll just leave it as 2 over 3. But what about the x part? It goes, perfect. It goes down below because 8's bigger than 6. And 8 minus 6 is 2. So that lets me know what the exponent's going to be. So let's see here. Let's keep trying some of these out. What about 6? All right, start with the numbers. 9 divided by 3 is 3. Again, bigger number up top, so my 3 goes up top. Okay, so my x's, where's the bigger one? On the bottom. So I know my answer is going to end up there. So what's 7 minus 3? 4. So bottom x to the 4th. Okay. What about my y's? Where's the bigger number? Top. 5 minus 2? 3. And I'm good to go. Now, are there going to be some times that we end up with some sort of fractional thing and it doesn't come out nice and clean? Yes, that can happen. Yep, I will have it back up here in just a sec. But I'll get back up in a minute because we've got to keep kind of going along here. It's unfortunately one of the things that happens when we miss bits and pieces, but I will get it back up in a bit. So let's say we get to number 8. Now I'm like 24 over 10, so I punch 24, oops, let me get the negative in there. So I punch negative 24 over 10 into the calculator, and I get a decimal. Well, I don't want decimals. Well, I wonder if the fraction reduces. Well, if I hit math, enter, enter, well, that's better. Okay. So negative 12 over 5, because I can divide each of them by 2, basically. But that's what I'm looking at here. And now I go into my exponent rules for the rest. Okay? So notice, exponent rules are different than just the numbers that are in front. So, same 2 questions. Where's my bigger exponent?
On the bottom.
Oh, on the bottom. I'm sorry.
That's why I said 5.
Oh,
5 over 5.
gotcha. And then just subtract. 9 minus 7 is 2. What about my y's? Okay, bottom, and it's y to the 6th. And I'm off and running. Ooh, I see one that looks like fun. Let me shrink this for a second. Now when I get to 10, even if I punch in the calculator, I'm going to find out that 5 over 7 I can't do anything with. What about the x's? Well, what's 2 minus 2? 0. I'm not going to have any left. So if they have the same exponent, they just cancel out. They go away. But then I can jump back in with the y's. Circle up the bigger one. 4 minus 3 is 1. And I'm ready to roll. I got one more I want to do on this side. One more. Number 12. Now, number 12. Here's why I want to do number 12 and why I have to be careful. A lot of us will look at that and say, ooh, 15 divided by 5 is 3, which is true. But you've got to remember in that case, 15's bigger, so that 3 has to end up down here. And some of you may even decide you want to put a 1 up top, which you could, but it wouldn't be necessary. Or you can just let the calculator do it. What about my b and my c? Where are they going to go and what are their exponents going to be? B's at the top. B or b to the first? Absolutely. And c's at the bottom because 3 is bigger than 2. 3 minus 2 is 1. What's that? Okay, there's a couple of reasons why I can put that 1 there. Let me pull this up. My first thing would be if I just typed in the fraction that I've got over here, so 5 divided by negative 15. Okay, I get this decimal. Math, enter, enter. It's negative 1/3. So when it says the negative 1, now you're like, well, why do you have the negative down here? The negative can go with either number. So if I'm not sure sometime on how it works, that's an option I have with the calculator that I can do. But in this case, as long as I have the negative 3 here, I actually wouldn't have to put the 1 up top. Bigger number, that's where my answer goes if I did 15 divided by 5.
But I thought you're usually doing 90.
Right, but that's only on exponent rules. The numbers in front don't follow the same rules as exponents do when I'm working with the variables. They just still divide. This is still like just doing 5 over 15. Okay, 2 separate things going on here. When I start this problem, let me do this for a second. When I start this problem at the beginning, I'm not even going to worry about the variables yet. I've just got this 5 over negative 15. If I'm just reducing a regular fraction like I normally would, I can divide each of those by 5. So 5 divided by 5 is 1. Negative 15 divided by 5 would be negative 3. And that's sort of where that negative 1/3 was coming from. Yeah, it's just, I'm just reducing a regular fraction. If I have to, I'm serious, just go to the calculator, type in the number part, and do it that way. But as far as the variables go, that's been the same all along.
Number 15.
Yep, 3 is bigger than 2, so 3 minus 2 is 1.
You got a note?
Yep. I'm just subtracting exponents and putting my answer where the bigger one's at. What's 3 minus 2?
Why are you doing
Okay, because I've
that?
got
What about the 1B?
this one.
Yeah. I don't get it. Like, I don't.
I'll come back to fractions later. I can't go back to regular reducing fractions here for a second. I'll get you set on it though. Because actually you're going to get to see it again on 15 here since that got requested. All right, let me shrink this down. Okay, so 15. Here we go again. 4 over 12. What's divides into 4 and 12? Ooh, some of you are thinking ahead here. Okay, 4 does. Shh, shh, shh. So 4 divided by 4 is 1. 12 divided by 4 is 3. Or, if I'm not sure, I always have the option of coming back to my calculator, and when I see it's a decimal, I go,
You're dividing the top number by the...
I'm just reducing a regular number, just like I would if we just had a paper and I said, here's 4 over 12. Reduce it as simply as you can. Okay? Because once I get that, find that bigger exponent. 7 minus 5 is 2, and since the bigger one's in the bottom, that's where my 2 goes. 5 minus 2 is 3, bigger exponent. Okay? And that's all we're doing here. Again, if the numbers in front are what's getting you, let the calculator be your guide. Let it tell you where the numbers go. Oh, the 1 goes on top and the 3 goes on the bottom. Okay. And go that route. Because we just don't want to get it messed up with our exponent rules. Okay? Now let me see here. Let me head to the back here for a second. So as we get back here, now we're going to start getting into some things. Let's go to 17, and then I want to hit the review ones right below it. On 17 now, negative 60 over 24. Again, that might be one that you don't know right away. Let the calculator help you. Negative 60 divided by 24. Okay, I get a decimal. Don't want the decimals. Never want the decimals. So that tells me it's negative 5 and 2. Tells me with the fraction where those go. Down here, what exponent's on B if I don't see one? 1. So 3 minus 1, bigger minus smaller, is 2. Bigger exponent's up here.
So the C just goes out?
Yes, if you get the exact same exponent, 2 minus 2 is 0. So if you have the same thing, they just cancel out, and I'm ready to go. Okay. But again, the subtract rule is only on the variables and their exponents. So down below then, now we can kind of start mixing and matching. So when we get to this middle part, now we get to go back to what we were doing yesterday. So when I'm multiplying, what's the rule when I'm multiplying with exponents? What do I do to the exponents when I multiply? Okay, so when I multiply, I'm going to add the exponents. Now I'm still going to multiply the numbers in front just like I normally would. They don't get the same rules. So 3 times 4 is 12. What's my exponent on my A going to be? Okay. 6 plus 2 is 8. Okay, that one's ready to go. If I have what's called power to power, which just means there's exponents with there's a parentheses, excuse me, with an exponent outside. Yep, we're going to multiply the exponents. So 3 times 5 is 15. Now notice the difference between 21 and 22. 22, the exponent's outside the parentheses. That's why I do the power to power rule. Here, they're inside, so I don't have to do that. So it's just a little thing for you to kind of watch out for. Now 23, there's all sorts of craziness going on. I see division, but I also see an exponent. So here's my suggestion. I personally would distribute my exponent first. And it goes to every part, every exponent that you see inside.
Multiply?
Yep, and we're going to be multiplying. So x to the 14th, y to the 10th, over x to the 4th, y to the 6th. And now I use my division rules that I was just talking about. We're going to subtract exponents. So 2 questions. Where are my x's going to end up, and what's my exponent going to be? So 14 minus 4 is 10. That ends up at the top.
You have to
Why
put it
are
on
you
top of
getting
anything.
4?
What's that?
Why are you getting 4?
This one? Because that 2, that exponent's going to all of my exponents. 2 times 2 is 4. Just like here, 2 times 3 is 6. Okay. Here, we decided we were going to distribute, we were going to do the multiplying part first. So 7 times 2 is 14. 5 times 2 is 10. Okay? So now with my x's, I'm going to subtract exponents. So 14 minus 4 is where this 10's coming from. Sort of like doing 2 separate things together in the same problem. And then it's the same with my y's. 10 minus 6 is 4, but the larger exponent's here. Now some of you may say, well, what happens? Everything's up top. There's nothing left down below. I can do one of 2 things. I could just circle this and say I'm done. Or I can just put a 1 down there if I wanted to keep it as a fraction. Either way would be fine.
Do you times the 2 by the 4? I don't know.
Yep, that 4 is going to go through to my A, to the 2, and to the B. So let's just write this first, and then we'll start simplifying it here a bit. So I've got A to the 4th, and then I've got 2 to the 4th times B to the 4th. Now, A and B are different variables, so I can't subtract their exponents. You can only do it when it's the same variable. But 2 to the 4th, I can actually get an answer out for. Just a reminder again, 2 to the 4th does not equal 8. If you're not sure, you can go to the calculator, and again, this little up arrow is called a caret, not like the ones you eat, is the kind of my exponent button. Oops, not 5 though, is my exponent button. So 2 to the 4th power is 16. So I'd write my final answer like that. Okay. But I need to simplify my numbers. Okay, I don't want to just leave it as 2 to the 4th. Kind of similar when we get to 25. Here's how this is going to work. That 3 goes all the way through. So I've got 6 to the 3rd power, which we'll figure out in a minute. And what am I doing to exponents again when I do power to power? Am I adding them? Okay, power to power, when we see the exponent, we're multiplying. So P, 4 times 3 is 12. 7 times 3 is 21. And then again, if I don't know what 6 to the 3rd is, because it's not 18, I can just come back here and do 6.
Sorry.
Yeah,
Give it back to me quickly.
sure. And I'm set. Now, there's one other thing that I don't have on the sheet right now that I want to just kind of show you how it works, just in case you run into it, which you very well may. So here's what we're going to do. We're going to scratch these. And we're going to put ourselves one more little part in here. So let me move this up a bit. What happens if I get a negative exponent sometimes. We haven't seen that show up yet. So what do I do? Well, if you get a negative exponent, you're going to flip it. Now you're like, what the heck does that mean? Let's say, for instance, we're only going to do a couple of these. And we'll see a couple of more. I'll start working through a little of the worksheet with you too. Let's say I had something like 4x to the negative second over x to the fourth.
You put -2, 4.
So yeah, what we're going to end up doing is anything that has a negative exponent is going to flip. So I start looking, I'm like, okay, 4 is fine. It doesn't have a negative exponent. X to the negative second, that's a negative exponent. We need to give it a positive attitude. When it flips down to the denominator, it becomes positive. So anytime I flip a negative exponent, it's going to become positive. You're like, well, do I flip x to the fourth? No, it isn't negative. You're like, dang, that kind of looks different. Yes, it does. Because now these two are being multiplied. So I'm going to add the exponents. So 2 plus 4 is 6, and that one's done. Okay, it's kind of weird. So like, let's do one more here. I'll do one that's kind of strange. Now again, personally, this is just me, I would do all of my flipping first. So I have x to the fourth, that's positive, that doesn't need to flip. Y to the negative third, bad attitude. Down it goes. And again, whenever you flip one of these, it becomes positive. That's the whole reason for doing it. X to the negative 1, does that need to flip or does that get to stay? Yes, it gets to flip because it was negative. So y to the fifth need to flip? No. And you're like, am I done? Almost. Now I'm multiplying, so I'm just going to add the exponents. They're both x. So 4 plus 1 is x to the fifth. 3 plus 5 is y to the eighth. So am I going to subtract the exponents now, or am I done? Can I do 8 minus 5? Yes, I can do 8 minus 5? No, why not? They're not the same. And I'm good. So, here's what we're going to do with this now. I'm going to do a couple of things to help you out on this sheet that we're going to work on together. One of the things, which I'm going to come around with here momentarily, is a help sheet that hopefully will help us as we get into doing these. And this is another one of those things, if you want to use this on a quiz or a test, you can. I think I may be getting a few extras in here as I go, but that's okay. So once we get these out, because it's all the rules in one, even a few examples there to help you out. Oh, okay, thank you. So, refer to this as we take a peek. This is the homework. This guy is the homework.
Which one was the Santa?
Huh? Practice B. So, we are going to take a peek, maybe. All right, let's take a peek at a couple.
It's like a grade B.
1, 2, and 8 on the front. Here we go. Multiplying. What am I doing to the exponents? Okay. So I see this 2. I don't see any other numbers to multiply with. I'll just do it. Which exponents can I add? Okay, the m's. So 1 and 3 is 4. And I only see one thing with n in an exponent. So I just write that part down. Number 2, it's like, ooh, these are getting kind of long. One question, because we haven't talked about this yet. What's anything to the 0 power equal? 1. So basically, if I see something to the 0 power, that piece can go away. Now in this case, there's no parentheses, so it's just the y that it's doing it with. So, multiply my coefficients. Okay, it'd be 24. What exponent's there if I don't see one? 1. So let's see here. X to the 3rd, and that's 4, and 3 more looks to be 7. And a y to the 1st, and a y to the 2nd is a y to the 3rd.
I got it right, but I accidentally put the y first.
That's okay. Yeah, the order of these, if you put 24, y to the 3rd, x to the 7th, that's absolutely fine. It's the same thing. Okay? So it kind of gets us going a little. One more here down below, and then we should get you into today's. Exponent. All the way through. So I've got a v to the 4th. And what am I doing to exponents when I'm power to powering again here?
Does that say 4, 7? You're adding the
Multiplying.
4, 4. Oh, yeah. Sorry, does that say 4, 4?
Uh-huh.
I need to get my glasses.
So 4 to the 4th, I can punch that into my calculator. 256. And can I add the 4 and the 16 that are exponents? No, different variables. Okay, I'm done. So it's just getting used to the rules, but again, use the help sheet. Oh, let's find one more. What looks like fun on the back? Yeah, 18 looks like fun. We'll finish with a big goofy looking one. Okay, inside out, stay with me. So here up top, I'm going to distribute this 4. So I'm going to get my big parentheses in here still. So I've got a to the 4th and b to the 12th, because that's 3 times 4. Down below, that 3 is going to distribute through. So 2 to the 3rd power, let's see, 2 times 2 times 2 is 8. And 4 times 3 is 12. Oh my. So now that we're rid of the first set of parentheses, we always work from the inside out. She's pondering. Talk to me.
Because I was like, why did I thought you just put the 2 and then you put the 3?
Yeah, I could write this as 2 to the 3rd. I just went one step ahead on that. Yeah, that's fine. And then finally, one more distribute. So 4 times 4 is 16.
That's 4 squared, not 4 whatever.
No, there's the 4 out here.
You have to times?
Yeah, we're just times them. Yep, that's your exponent rules. 12 times 4 is 48. 8 to the 4th. I even need help on this one. 8 to the 4th. That's going to be a big number. 4,096. Okay. And 12 times 4 is 48. Okay. Whew, let's see. We got anything left here? Yes, the A's. We can still work with the A's. Okay. Scooch a little further over here. So my B's aren't going anywhere. My 4096 isn't going anywhere. So 48 minus 16 is 32. Bigger exponents down below.
But they're both the same.
Right. So we're just going to subtract and put our answer. Ooh, that was kind of a doozy. Okay. So these are just going back over that. Tomorrow, same idea. We're going to be kind of going back through the different types. There's no more new twists to throw your way. We've Yeah, it's all there. So, kind of work these. There'll be some work time tomorrow. We'll be kind of doing a preview together. It might be time to bust out the candy again. And we should be good to go.